All right, team, this lesson is on rational expressions, and we're going to start here with an example, sort of a real-life situation, to sort of motivate our learning, tell you why we're doing what we're doing. This example has to do with shoveling. This is called a work problem, this type of problem is. And we're going to use an example that is probably familiar to you as a Chicago kid and is probably coming up in your life sometime soon, given the time of the year it is, right? So imagine you're shoveling out a spot with your dad, and as we know, the Chicago tradition is once you're done shoveling, you and dad are going to leave some trash there to sort of stake your claim, right? So that's what we're doing, and we are given that you can shovel half the spot in an hour, right? So you shovel half, and your dad can shovel a third. So remember, a third is smaller than a half, so your dad's a little bit slower than you are. And the question is, how long does it take us together to clear this spot? Well, this situation is a pretty easy situation to write down. So you shovel half a spot per hour, and dad shovels a third of a spot per hour, and you guys are working for X hours. And how much do we want to shovel? We want to shovel one whole spot. Okay. So this is actually not a new type of math. This is really it's a one-step equation. We just have to combine like terms, right? The trick is we have to remember how to work with fractions. So notice I have different denominators. I have a 2 and a 3. And I want to add these numbers together, but before I do that, I have to make them the same, right? I have to make the denominators the same. So I'm going to multiply your coefficient by 3 over 3 and dad's by 2 over 3. So this should be a review, even if you're a little rusty. Notice what that does is it gets us 6 as a common denominator. So you're going to have 1/2 is the same as 3 over 6, and 1/3 is the same as 2 over 6. And then I can add those numbers together, right? Because my denominators are the same, and 3 plus 2 is 5, 6. And then I want to divide by that number. And the way I divide, right, is it's the same as multiplying by the reciprocal. So that's 6/5 hours. So that's about an hour and 10 minutes, hour and 12 minutes actually it is. So together, you and dad, it takes you a little bit over an hour to shovel a parking spot, and we'll assume that includes putting your trash there as well. Okay. So that is an easy example of working with these fractions. And as long as you know your fractions rules, you didn't need anything new to do that, right? So this is kind of a baby problem. Now let's complicate things a little bit. And we're actually, by complicating things, going to make it a little bit more realistic. So the question now is, if we know that you and dad take a certain amount of time working together, can we figure out how long it would take you by yourself? So it takes your dad 3 times longer to shovel, and together it takes the 2 of you 1 hour to clear your spot. So we got a little faster since the last problem, I guess. So the way I model this, right, if I'm trying to figure out my individual rate, well, I don't know that it's 1/2 of a spot per hour anymore, right? I know it's 1x of a spot per hour. So that's you. And if your dad, well, if your dad takes 3 times longer, 3 times x is 3x. Okay, so here's my hour or your hourly rate plus dad's hourly rate equal to the 1 hour total. Now notice with our x's on the bottom, we have a different type of problem, right? So here what we need to do is combine our rational expression. Okay, and the way we're going to do that, well, we're going to use the same type of math as we used before. So we found a common denominator, we're going to do the exact same thing. So notice I have x and then I have 3x. Okay, so I need to turn these into the same number. I'm just going to multiply times 3 over 3 over here. And I can leave the other one the same, because 3x, well, 3 times x is going to give me my 3x, right? So the result is 3 plus 1 on top, and then 3x as my common denominators on the bottom. Okay, 3 plus 1 on top is 4 over 3x. And now I can tackle this a couple different ways. If you want to think of it as cross-multiplying, you can. Meaning I'm making my 1 a 1 over 1, and then I'm cross-multiplying. or I can just think of it as multiplying by 3x on both sides. Okay, so that's going to give me 4 over, nope, just kidding, 4 equals 3x, and then x equals 4/3. All right? Okay, so that means it takes you 4/3 hours to finish. And dad is going to be 3 times that, right? So dad would be 4 hours. So you better get out there and help him, right? All right. So that's a really simple example of a rational expressions problem. Again, this is called a work problem. And the type of math you might do as a manager, if you're scheduling people, is this type of math, depending on what types of tasks you're trying to get done. So that's one reason we're doing this. Another reason we're doing this is because more complicated versions of this type of problem show up in the SAT, and I need you to be able to do it in AP Calc as well if you choose to go on. The main idea here is that we're following all the same rules as fractions, okay? So let's make sure we understand those, right? So to simplify these things, a fraction, we're just going to pull out a common denominator, the top and bottom, and cancel them out, right? So this looks really familiar to what we've been doing. To add or subtract, we need a common denominator, right? So here's an example of that. So I choose a factor to multiply each fraction by to make our denominators the same. And notice it does not have to be the same factor. And it does not have to be, in this case, 9 times 6, right? I saved myself a little bit of work by realizing that 2 times 9 is 18 and also 6 times 3 is 18. And then multiplication and division, these are the easier ones, right? So multiplication, I just go straight across, multiply the tops together and the bottoms together. Division, I do something similar, but first I change the divisor to the reciprocal, right? So multiplying by 3/2 is the same as dividing by 2/3. Okay, so make sure you understand each of these examples and make sure your notes are complete before you move on, because we're going to do the same thing with harder expressions on the next page. Okay, so here are some algebraic examples, and the nice thing about these is that it allows us to practice the factoring skills we've been working on all year, and really if you're good at that, you're going to be good at this. So my first example is the easier one, and the first thing I'm going to do is just rewrite as multiplication by taking the reciprocal of the second, and then I multiply together. And notice what I have ahead of me is a really complicated distribution problem if I choose to go that way. The way we're actually going to tackle these is by simplifying first, or factoring first. So what I've done here is I've factored the top and bottom. So for example, this piece is equivalent to this piece. And you should at this point in your life know how I got that. And then I factored also the x squared minus 16 on the bottom. And notice what happens here is I get some common factors on the top and bottom. So I can cancel this out, and my result is just what's left over. So that's much easier than trying to multiply that all together and then simplify. Okay, so I can leave it factored like this, or if I wanted to, I could multiply these together using a Punnett square. Okay, so just an algebra rule here. And that's my final result. Now, addition and subtraction, here this is a little bit harder. Okay, and I want to start by recognizing that my denominators are different and that my left-hand denominator, this can be factored, right? So notice how once I factor that bottom, it makes it easier to see what I need to make a common denominator. So I'm going to choose to multiply top and bottom. Whatever I do to the top, I have to do to the bottom, and vice versa, by that x plus 3. Because then doing so makes our denominators the same. The other thing I'm going to do is I'm going to throw a plus here and stick the negative on my 1. So I'm going to turn my subtraction into addition, and the reason for that is then I know to distribute the negative across both pieces. So what I get when I add, so I've distributed my negative here, and then I just keep my denominator the same. Okay, then look what happens up on top here. So here I have to do a little bit of algebra. My x's cancel out because I have an x minus x, and then 5 minus 3 is 2. And again, that's my final answer because I've just been asked to add these, so my result is going to have an x in it. Right? So again, we're following the exact same rules as we have always followed with fractions. We're just dealing with big boy fractions, more complicated fractions here. So here are the notes, and good luck as you move on.